Welcome to Brain Vision.
So here we have a um, section of the silver ribbon, and we know that the drift velocity is related to the current density by this equation, and current density is given by current over area, which is equal to y1 times z1. So using this equation, we find the current density and use this value of current density in this equation to find the velocity. And that comes out to be 4.7 times 10 to the power minus 3 meter per second. Now, for the second part, we know that in order for the net force to be zero, the electric field is determined. We have to determine the electric field. In order for the net force to be zero, the electric force should be equal to the magnetic force in magnitude, and the directions of these forces should be opposite to each other. So we write these two forces. So electric force is the magnitude of charge times the magnitude of electric field, and the magnetic force has magnitude q mod times the drift velocity times the magnetic field, which only has a component along y direction. And we simplify this equation and we find the electric field to be this value, and we solve this and we get the magnitude of the electric field to be 4.5 times 10 to the power minus 3 volts per meter. Now for the direction, we know that the drift velocity of the electron is in the opposite direction to the current, and by right hand rule we get the cross product of v and b to be along the negative z direction. So as you see here, our positive z is downward. So v cross b is along the negative z direction, and we have the magnetic force to be charge times this cross product, and since charge is negative for the electron, the magnetic force is in the positive z direction. And from here we can say that the electric force should be along negative z direction from this equation over here. And since charge is negative, the electric field should be opposite to the electric force. So the electric field should be along positive z direction. Now the Hall EMF is the potential difference between the two edges of the strip at C equal to 0 and Z equal to Z1. So using the results from part B, where we found the magnitude of the electric field, we can find this EMF, which is going to be equal to the magnitude of electric field times V1, and that gives the EMF to be 53 microvolt, or we can say 53 times 10 to the power minus 6 volt.